Hello everyone. In previous videos, I introduced how we can program the safety logic. So after we program all the safety logic, we still find some important tags. For example, the EDM signal or the safety reset signal, which should come from the standard PLC, transfer from the standard PLC to the safety PLC. We haven't connected those signals yet. So in this video, I will mainly introduce how we can exchange the signal between the safety PLC and the standard PLC. So firstly, let me show how we can transfer some signal from the standard PLC to the safety PLC. And I will pick the three signals as an example. The first example signal, that is this. The arrow acknowledge, group port acknowledge. This acknowledge signal controlled by a tag, which means arrow acknowledgement. That tag stay here, arrow acknowledgement. So we need to use the one signal from the standard PLC to control this arrow acknowledge to allow us to press one button or enable one signal to acknowledge the arrow in the safety logic. The second signal I will show, that is the EDM signal. According to our application diagram, for example, for the e-stop loop, we already programmed the safety input, safety output, as well as the core logic. However, we haven't connected this area. For example, the EDM signal. As shown in the screen, this K1 and K2 come from the relay K1 and K2. And this K1, K2 EDM signal, that is a normal closed, come from the relays. And both signals come from the standard card. And for the reset, usually this reset signal also comes from the standard PLC. And for the EDM, if an EDM signal, usually the actual drawing like this. For example, the drive enable EDM signal. That comes from the drive relay. We use the two relays output. That is a normal closed signal. Give a feedback to the standard signal card. And the third example, that is this restart. It also comes from the standard PLC. Firstly, we need to create the tags from the standard PLC area. So that is a standard PLC area. So to create the tags, we go to the global list, GVLS. So add a global variable list. Usually, in actual project, I will prefer to create three groups. For example, first one, that is the cell. Or you can code control. And second, you can create I/O. And all the physical input and output channels are here. And third, you can create one named safety. And all the signals are used to exchange the data between the standard PLC and the safety PLC. We will create the tags under this folder. So we double click this safety and create a tag. The first one, for that acknowledge, we call it TS, transfer safety Q, ERRACK. Keep in mind this format, AT%Q star bool. This format means this is the tag name. This Q here, that is my definition, which means the signal from the standard PLC to the safety. Because from the standard PLC side, that is a Q output. And a bool means that is a bool signal. Other than this, I will create another two. One is used to the table drive EDM signal. One is the safety reset global 1 pump button. 3 output signal. So after you create the tags here, keep in mind you need to build your solution. allows your system refresh this area and create this tag rather than the text only. It creates a real tag in your system. We won't care about the error temporarily in the safety. So we go to our logic here. Firstly, let's go to this error acknowledge. So this error acknowledge input its alias name is here. To connect this safety signal TSQ, sorry, that is a error. To connect this tag to this, we need to double click this alias device tag, double click. And from this link, we click this button and it pop up these three tags we just created. So we click this transfer Q error acknowledge. So that means this alias tag plays a role like a bridge. This alias input tags will connect the signal from the standard PLC to this tag and then used in the safety. And this tag name here will used in this variable mapping list. Because in this mapping list, for example, the EDM, we can see from this EDM here, you cannot directly find the tag from the standard PLC. We must use the alias tag created here running as a bridge to connect the standard PLC tag and connect the variable mapping list here. So according to the tag name, we will connect the table drive EDM, right? So in the safety logic, that EDM signal is here. The safety tag name table drive EDM is here. Currently, this table drive EDM haven't connected everything yet. So we need to create one tag here, one input alias tag here. From the safety PLC wheel, this signal comes from the standard PLC. So that is the input of the standard PLC. So from here, we click the right, add new items. We create one digital input from the standard. Click the add. And we rename this. If this tag will connect with this, I will rename the same name with this tag. So we will rename table drive EDM. And we could also add a prefix name here. Alias. Give a name alias here. So in this table list, this table drive EDM, that is this channel. Let's click this button, connect this safety tag to this alias tag name here. Click. Let's go to find. So we can see the tag we just create is here. That is the alias table drive EDM. Let's click this in. Click the OK. So from here, which means we connected this safety tag with this alias tag here. And after that, we need to connect this tag to our safety tag. Connect this tag. So let's double click this alias table drive. Click and click this TS_Q table drive EDM. Using this way, you can see this tag can be used as a bridge. Connect the tag from the standard PLC and from the safety area using this variable mapping So the actual safety tag will connect this alias tag here. So next, if you recall, for the reset signal, to reset the light curtain, we have a tag named Safety Reset Group 1 Palm Out button. So this safety tag is here. You need to connect one alias tag here. So let's use the same name, copy this name. And from here, let's add a new item, one digital input. And from here, let's rename that. Give a alias, copy, safety reset group 1 palm out, add. So we create a name here. And after this, let's connect this safety tag to this alias tag. Safety reset group 1 palm out. Click. Find out alias safety reset group 1 palm out. Click this in. Click. And after that, double click this safety reset group 1. Connect the standard PLC tag. This safety reset group 1 palm out. So till here, I need to mention, you can see basically for one signal, we have a 3 area. One is a standard PLC area, one is an alias name, and one is the tag in that mapping list. To align them together, I will prefer this core name. If this is the same signal, the core name, you'd better use the same name. And the prefix would be a little bit different. For example, from this standard PLC, I used the TS_Q or I. And from this alias area, I add a prefix alias. And from the safety, it used is a pure name like this. If the core name they are the same, it's easy for you to find out the relationship between the standard PLC, alias tag, and the safety tag. Because there's no way to go cross-reference to find out where is this logic come from, where is this signal controlled, right? So you better use the same name, follow this path from here, and from this mapping list, go to the alias area and go to the safety area. You better use the core name is the same. You better keep the core name is the same. Okay, that is the 3 signal come from the standard PLC. We do have some signal need to transfer from the safety PLC to the standard PLC. For example, for each function block like this, vertical light curtain OK, E-stop MCP OK, those signals are after the function block, right? Sometimes HMI need to create one IO list. In this IO list, it can show the light curtain status, E-stop status, and gate status, and the table switch signals. Those signals need to be used as a normal signal showing in the HMI. We do need to transfer some signal from the safety PLC to the standard PLC. So let me show how we can do that. Go to the safety. Let's create a 3 typical signal here. Firstly, I will create TS, I, E-stop. It's very typical. E-stop, MCP, OK status, AT, %I start, comma, B bool. Which means this represent E-stop at a MCP panel OK status, and %I start, which means that is the one input signal for the standard PLC, come from outside, and this is a bool signal. Same way, I will create another tool, gate cell OK, and tool in cell enable. So let's build it first. Keep in mind, every time you create a tag in the standard PLC area, you need to build your solution. And let's shift to the safety PLC side. Firstly, let's go to the eStop MCP OK signal. So this eStop MCP OK, that is the output of this function block here. So this safety tag is here. It haven't connected any alias tag here. To transfer this signal from the safety logic to the standard PLC, we need to create the alias devices tag, that is the output tag. Right click here, add new item. Click the digital output standard. Add here. And from here, let's rename, which is a alias, right? And that full name, that is a eStop MCP OK. And after that, let's connect this eStop MCP OK. Let's click here, connect to this alias name. That's alias name, that is the alias eStop MCP OK. Click this out, connect. See? And after this, let's double click this alias eStop MCP to connect the standard tag from the standard PLC. So click this link to. And from here, we can see this TS underscore input eStop MCP OK, which means this tag will transfer the signal come from safety PLC to the standard PLC. For the standard PLC, that is the input. Click the OK. We finish this channel. So the next, that is the gate cell OK. Next one, this gate cell OK signal. This gate cell OK, create another one, add new item. Digital output, that is called alias and gate cell OK. Here. And let's find the gate cell OK signal in this list. Which is here, gate cell OK here. And let's connect to this alias tag here. Click, connect this alias gate cell OK out. And after this, double click this alias gate cell OK, connect to our standard tag. Click, gate cell OK, come from the standard PLC. Click OK. This finished. The two tags we just create, that is the eStop MCP and the gate cell OK signal. That is the input area. Let's go to the output area. Let me use this tool in cell enable as an example. Usually we need to use the HMI to show the enable signal from those safety logic. For example, we need to use one indicator show the tool enable status. We need to show if this tool enabled by the safety or not. So which means we need to transfer this safety controlled results, this enable result signal status, to our standard PLC. We use the same name. Create another tag here and create another alias tag here. Add new item. So we'll create alias tool in cell enable. Add. And after we create this alias tag, go to tool in cell enable. here. So here, that is the one special case I would like to show. So we know this tool in-cell enable, because this is the safety output, other than the tag connect to this function block that is here. We already use this tag connect to the safety output channel. Especially for the safety channel, we connect the extend and the retract enable. Right? So we can see it's already shown here. And from here, we also need to transfer this status to the standard PLC. So which means, other than this tool already, we also need to add this alias tag to here. How we can add this? Basically, we have two ways. One way is, let's directly click this. And other than this tool, when you select this alias tool in-cell enable, keep in mind, press the control and click this out. Make sure you select the 3 of them. Make sure you select all of them and click the OK. And after this, you will see this tag connect the 3 of them. And second way, you could use this safe decoupler. Drag this tag here. Drag this function block here. And connect this tag to here and create another name. For example, similar tool in-cell enable, and we can name tool in-cell enable to PLC. Right? And after this, so which means this will only used to connect the physical channel, and this is only used to transfer the signal to the standard PLC. We separate this function rather than connect this one tag to 3 ports. Basically, we have 2 ways. And keep in mind, after we connect this area, we need to click this alias tool in-cell enable, double click, and linked to the standard PLC. That is this, TIS_1 tool in-cell enable. Till here, we connect all of them. These 3 tags are just an example. We also need to connect a lot of standard PLC tags into this area. Ideally, all the gaps in this mapping list, we need to connect the alias tag, and after that, connect the alias tag linked to the standard PLC tag name. So till here, we can save your project. It will show there are validation errors. Continue. Yes, we want to save. And let's firstly verify our safety project. So after we compare, we can see, so this is a very important error. Run stop haven't connected yet. So to solve this, let's go to the variable mapping. Go to the group ports. So other than this error acknowledge, we need to connect one acknowledged signal from the standard PLC. We also need to connect one thing, that is a run and stop. Usually we need to give a true signal from the standard PLC to safety PLC. So from here, let's firstly create one run and stop signal, which is the input. Alias safety run stop. After this, let's shift to the variables. And from here, let's create a new tag. Create new tag that named safety run stop. Okay. And from here, let's click the input from the alias safety run stop. Alias safety run stop. Click this. Okay. And this, click. We need to connect this run stop from this TwinSAFE group 1. Here. Click. So after we connect here, if we shift back to this group ports, we will see this safe run stop already connect. this safe run stop comes from this tag, and this tag is connected with this alias name. And in the standard PLC, we need to create one standard PLC, connect to the standard PLC, run and stop, and then give a true. Let me create this. Go to safety, and this is the output signal. TS. Q. Safety. Run. Stop. So create this output signal. Build. And after that, let's double click this safety run stop, connect, linked to the standard PLC tag, this tag, TSQ. We just create, click OK. Usually we want the standard PLC give a true signal, always true, to this safety. We want to keep running the safety logic. So usually if we go to the main, we need to give a true signal to this tag. This is that tag. So we need to give a true signal to this tag. So a pop-up like this, red wave here, what's the reason for this? That's because if you need to use this global tag, because this tag is located in this safety page. So when we use this tag, we need to type in safety dot ts safety run stop. That is the full name of this tag. That is how we can use this run stop. Also, you can program some conditions to stop the safety logic by some special case. From this compile result, we can see a lot of errors. It shows a lot of tags haven't connected yet. And those EDM we haven't connect for the safety output or for the monitoring function block. If you assigned this EDM signal, you must connect the EDM signal to somewhere from the standard PLC or from the safety channel. You must assign where this signal comes from. So that's why, to prevent you forgot something, once you go to the verify safety logic, it will pop up the error. We can see that. Ideally, all those empty columns need to be filled with the actual signal here. Other than those common errors, which basically show you need to connect the tag, they are not used, they haven't connected yet. Other than those, there are still two important messages showing on the top. Your target machine could not be found, and your target system safety control is not reachable. How we can solve this? There are some important settings in the target system. Till now, all the program we did, that is offline programming. The software need to identify this hardware address. The TwinSAFE software need to identify if this safe address identical with this hardware address. So ideally, we need to connect the actual controller and shift the controller to configuration mode and do an upload, check the hardware address first. Then do the safety verify again. And after that, if this safe address and online hardware address, they are identical, after this two error message will disappear. So in next video, I will show how we can go online, read this hardware address, and how we can verify the safety address and do online monitor on the safety logic.
Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe. See you in next video.